boys and girls, for today's math lesson, let's start off by looking at our objective. Our objective is to use basic facts to multiply mentally by multiples of 10, 100, and 1,000. So those basic facts are just the facts that you've been practicing the whole time you've been in school that you should just kind of know offhand, such as 7 times 8, 3 times 5, 2 times 9, just those simple facts that you know without even thinking about it. We're going to use those to help us multiply by larger numbers. So let's get started by looking at our first practice problem. Our basic fact for number 1 is 7 times 8 equals 56. You can see that we have 7 times 8 times 10 to the power of something. So this is the first power of 10, the second power of 10, and the third power of 10. So it tells us that 7 times 8 is 56. So we know that we can go ahead and put 7 times 8 is 56 for all of these, right? So we're multiplying 56 by the first power of 10, the second power of 10, and the third power of 10. So when we have 56 times the first power of 10, what is our answer going to be? 560. If you remember from our video yesterday, when we talked about having 10 to any power, that power or that exponent helps us know how many zeros we need to add when we're multiplying, right? Because if you think about it, the first power of 10 is just 10. So we multiplied 56 by 10. In our next one, the second power of 10 is 10 times 10, which is 100. So we're multiplying 56 by 100, so we need to add 2 zeros. So we get 5,600. So when we multiply 56 by the third power of 10, how many zeros do you think we're going to add? Great job. 3. So we get 56,000. Let's move on to our next problem. We have 2 times 5, which is our basic fact, times the third power of 10. The first thing we need to do is determine our basic fact, because it didn't give us the answer like it did in problem 1. So, what is 2 times 5? 10. So we have 10 times the third power of 10. So we have our basic fact of 10. How many zeros do we need to add? 3. So 2 times 5 times the third power of 10, our answer is 10,000. Problem 3, we have 6 times 3 times the fifth power of 10. So what is 6 times 3? 18. How many zeros are we going to add since we're multiplying by the fifth power of 10? You got it, 5. 1,800,000 is our answer. Okay, now we're going to take what we just practiced and try to solve 5,000 times 30. So in these problems, they gave us our basic fact and asked us to multiply by a power of 10. This time, we're going to determine the basic fact and work our way up to solving this problem by multiplying powers of 10, okay? So when we look at 5,000 times 30, we're going to find our basic fact by looking at these digits right here, because they are only digits that aren't 0, right? So our basic fact is going to be 5 times 3. Well, boys and girls, we know what 5 times 3 is. What is 5 times 3? 15. So we can go ahead and fill in our basic fact right here as being 5 times 3, which we know is 15. Well, we can't just put our answer as 15, right? Because we'd be leaving out these zeros. How many zeros are we leaving out? 4. So we are going to have to multiply by the powers of 10 until we get to the 4th power of 10. So let's start. 15 times the first power of 10, 150. 15 times the second power of 10, 1,500. 15 times the third power of 10, 15,000. And 15 times the fourth power of 10, 150,000. So, what is the answer to 5,000 times 30? 150,000. So just to review that, we took our basic fact of 5 times 3, and we knew that we had 4 more zeros that we can't just let go away or forget about in our problem. So we had to take our basic fact of 5 times 3, which we knew was 15, and multiply it by powers of 10 until we got 4 zeros, right? So we found our answer by saying 15 times the 4th power of 10. Great job. So we're going to work on doing the same thing in chart form. They gave us a sample, so let's look at that first. They said 800 times 80 is the same as 64 times the third power of 10. So they looked at these first 2 digits in their numbers, 8 and 8, and they said 8 times 8 is 64. Well, how many zeros are on 800? 2. How many zeros are on 80? 1. So we have 3 zeros that we can't just forget about, right? So we need to multiply 64, our basic fact, by the third power of 10 because we had 3 zeros after our basic fact. They gave us one more example. Let's look at that and then we'll fill in the rest of the chart. 9,000 times 90. So our basic fact we're going to get by looking at our first digits. 9 times 9 is 81. And we're going to multiply that by 10 to the what power? Well, let's see how many zeros we have. 1, 2, 3 zeros in 9,000, 1 zero in 90. So we have 4 zeros total. So we're going to multiply 81 by the 4th power of 10 because we need 4 more zeros. So let's try to do this on our own. 6 times 80. So we have 6 times 8. What is 6 times 8, boys and girls? That's right. So when we have our basic fact, we're going to multiply it by 10 to a power. Well, what power are we going to multiply this one by? 1, right? Because we just need 1 zero. 6 times 90. What is 6 times 9? Good job. Times 10. What is our exponent going to be? 1. Because we just have 1 zero. 6 doesn't have any zeros. 70 times 80. 7 times 8. 56 times, well, how many zeros do we need? 70 has 1, 80 has 1. So we need 2. So we have the second power of 10. 70 times 90. What is 7 times 9? What power of 10 are we going to use? How many zeros? 2. We just have 2 more to go. 800 times 90. So we're at 8 times 9. What power of 10 are we going to multiply by? 800 has 2 zeros. 90 has 1 0. So we need 3. So we have 72 times the third power of 10. 9,000 times 90. 9 times 9 is 81. What power of 10? Oh guys, you know what I just realized I did? I said 9,000 times 90. But that row that that's on, that's 80, not 90, right? So it's not 81. What is it? 72. So 72 times what power of 10? 9,000 has 3 zeros. 80 has 1 0. So we need 4 zeros. So we have 72 times the fourth power of 10. And this is just an easy way to help you figure out those big multiplication problems without having to write it out and say 0 times 0, 0 times 0, bring down a 0, 0 times 0, without having to deal with all those zeros and bringing them down and moving them over. This is a simpler way to solve those problems. I hope that makes sense. If you have any questions, please hit that little mail button on Schoology and let me know. We'll have a short assignment below. I hope you'll have a great day.